Functional notation. Functional notation. Okay. So if f of x is what you see, evaluate f of 1. So straight. So whenever you see x, you put 1. That is f of 1, right? So I have my function here, 3x cubed minus 2x squared 5x minus 1. F of 1. I have 3, 1 cubed minus 2, 1 squared plus 5, 1 minus 1. Now what are you going to get? What are you going to get?
5.
So this is 3 here, right? 3 minus 4 plus what?
3 minus 2.
No, okay, 3 minus 2 plus 5 minus 1. What am I going to get here? I'm going to get 5, right?
Yes, sir.
Okay. So welcome to functional notation. Remainder theorem. The remainder theorem. So f of x is this. What is the remainder when f of x is divided by this? Yes, I can still use my long division. I'll use my long division method, do it and get my remainder. As usual, maybe that's 2 final year, right? I can also use a remainder theorem to do this work very easy. So from remainder theorem, it follows that x minus 1 is equal to 0. So x equals 1. So you see this is a factor. Now I have the root, right? And I'll now substitute that into the expression. That is the expression up there. Good. You get it. What is the remainder when f of x is better by x? Yeah. You get it. Now what was I saying?
Negative 6.
Negative 6. If you're not so sure of yourself, right, you know what you do. I use the long division method. You solve it. Use the long division method like this. You get what? Negative 6 as a remainder here. Okay? Good. Welcome to the remainder theorem. So, welcome to the factor theorem. If x plus e is a factor of the polynomial this, so it will be stated, right? Then f of a equals 0. So that's a remainder theorem, right? So if x plus a is a factor, right, then f of a equals 1, 0. Now look at this. Factorize this completely. So here's how to put the question. Factorize this completely. Now what do? You first have to test for the values of the constants this. So it means which factors can go into this constant. That's 2. Not a variable. 1 can go, 2 can go, right? It can be minus 1, positive 1. Minus 2, positive 2, and that is all. 3 and 4 cannot. So when you get that, if it is a factor, it will produce 0. If it does not produce 0, it's not a factor. So when you get a factor, and you take that through the long division method, right? I also give you an alternative to this. So you test for the constants. So let's start by test for factors of constants. The constant is what? Minus 2, right? I can have plus or minus 1 here. It means minus 1 can do, positive 1 can do, comma. Positive 2 can do, minus 2 can do, okay? Or can't positive 2 and tap minus 2. That's possible. And that is all, right? So test. So let's test. So let's say I'll first start from f of minus 1, right? Okay. F of what? Minus 1. So I'm going to start from there, right? So this is 4. It is minus 1 cubed plus 8. You have to test till you get 0. I think everything here will give me 3. Just check for me. So minus 3 will get 3. Negative 3. Right, so watch. It means x plus 1 is not a factor. Now what's something here? Let's say you use minus 1 here. Why are you saying x plus 1? It is through this concept equals 0. That is when you can get minus 1. Are you okay? Positive 3, right? Good. So it is through this concept that from the factor theorem that you can get minus 1 here. So remember, the factor is this. And from the theorem you have this one inserted, right? So it is actually s plus 1, which is not a factor. When you put s plus 1 equals 0, now you still get minus 1. Good. So don't say s minus 1 is not a factor. No. Good. Now the next one, you test another one again. You're not so sure, right? Okay. So here you can go when s equals positive 1. Let's go. F of 1 equals 4, 1 cubed, 8, 1 squared minus 1 minus 2. Yeah, that's what are you getting here? 9. So it follows that x minus 1, right, is not what? A factor. Okay. So you keep testing, right? Test it till you stop testing. So let's say when x is 2. Let me go this way. When x is 2, right? Okay, so f of 2. Let's go. 4, 2, cube, 8, 2, square, minus 2, minus 2. Check this one for me. What are you getting? 60. 60. Wow. Try this one too. When x is minus 2. Let's go. Minus 2. 4, minus 2, cube, 8, minus 2, square, minus 2, minus 2. Good. You have to test for the constant, right? But if you know that it will give you 5, this gives you right. You can also do random tests. You can't tell whether it's so you can check and see what can give you the 0, right? You do random tests. Okay, so therefore x plus 2 is what? It's a factor. Do you agree? So if s plus 2 is a factor, what is it? You yourself said it's a factor, right? It means it can divide the polynomial. So when they say factorize completely, that is what we go through. Are you okay here? So that is, I as you go to master this, right? This will go here, it will be 4x squared. Remember? This by this will give you what? 4x cubed. This by that will give you what? 8x squared. Then 0, 0. In the name of subtraction, you remember? 0, 0. So I have minus x here, minus 2. Agree? Now x will go here, minus 1. Minus 1 by x will give you minus 1x. Now minus 1 by this will give you minus 2. So that is 0, 0. Or in the name of subtraction, right? So I have this. So this means now what's something here? And f of x is what? What I'm getting here. And this. These are all factors, right? And this can be reduced in the name of difference of two squares. What's here? So this is 2x. That's the difference of two squares. Do you believe that? Good. So you can have 2x plus 1, 2x minus 1, and this. So that is f of x. Good. You saw this long thing. I'm going to give you a very short alternative, right? Very concise. So look at it. So when they say factorize completely, after you get in the factor, you run through your long division. There is also 1, right? So these are all factors of f of x. Right? Good. Lower. Try the lower.
Okay.
Now that is it. There's a stretch how far we can go. Now let's look at this alternative. So can I also factorize completely and get this answer without going through this? The answer is a big yes. Okay, now this is what you do. This alternative has my function here. So this is f of x, right? Good. F of x. Since they are in 4 terms, you have the right method of moving. You see that? I have 4x squared out. It goes here as this x. This one goes here 2. Minus 1 outside, x plus or 2. Minus 1 into minus 2, that will be positive 2. But now watch here. 4x squared minus 1, x plus 2. It is over. Difference of two squares, x plus 1, 2x minus 1, x plus 2. Case close.
So simple.
Yeah.
Oh, okay.
That is it. So when we are doing mathematics, we have the way forward. We also